a model that is A equals 543.3 E 0.02 T. Describes the population A of a country. So this is population in millions. I always take notes. T years after 2003. So T equals 0 represents 2003. Use the model to determine when the population of the country will be 733 million. So how do I proceed? Yes, indeed. That's what we need to do. So we have to solve the equation. 733 equals 543.3 e to 0.02 t. Very good. First, I'm going to ask myself what type of equation is it. And when I answer that it is what type? It is exponential. Then I will know how to proceed. How do I proceed? Yes. Not actually divide, but I know what you mean. So 733 divided by 543.3 equals e to 0.02 t. Very good. And now I know that the next step has to be apply natural log to both sides. Very good. So natural log on this side, natural log on this side. So we have natural log 733 over 543.3 equals 0.02 t. I should write times natural log e, but natural log e is 1. That's why I don't write it. And then t equals natural log 733 over 543.3, everything divided by 0.02. So what do we have as the answer? How much? Is it? About what? Okay, so t approximately, I trust you. So I have to add 2003, so it appears in 2018 that had happened, assuming the model was still correct. Good. Moving on. Any questions on this problem? Is it okay, everyone? Yes? Okay, so we're moving on, going backwards to 14. The reason why we went backwards is because we had all those sequences fresh in our mind, and we decided to take advantage of that. So we did the sequences first, and then we kept going backwards. Ready now? So the formula which will be given to you describes the accumulated value A of a sum of money P, the principal, after T years at annual percentage rate R in decimal form, of course, compounded n times a year, yes. Complete a table for a savings account subject to n compounding periods per year. So we have the amount invested, which is definitely P. So I have to write, I'll copy the model. A equals P 1 plus R over N raised to NT. So A equals 21,000, very good. Invested amount 11,000. And we are told that the interest rate is 0.0625. And we're asked what is the number of years. So then we have 21,000 equals 11,000, and 1 plus R is 0.0625, and it was given to us to be 2, n equals 2, it's in the table. So then raised to 2 times t. Now we are capable of, we have the information to solve such an equation, which is a exponential equation. The exponent is the variable. Do not perform any operations other than simplify by 1,000 and divide both sides by 11. So 21 over 11 equals, do not perform this operation. There is no need. Raised to 2t. Right now it's completely cleaned up, meaning I can solve for t. Doing what first? I have to apply, yes, awesome. I have to apply natural log to both sides. So I get the natural log 21 over 11 equals 2t natural log, and I have to keep all this. The problem is that if you perform those operations, you may exponentially grow the error. So we don't want to do that. So we just want to find t as the ratio between this, natural log 21 over 11 over 2, natural log 1 plus 0.0625 divided by 2. This is what we want. So let's punch this in the graphing calculator. Natural log 21 over 11. Close the parenthesis, and now you divide by, if you do not put parentheses around the denominator, including that 2, you will not get the correct answer. Be very careful. So 2, natural log, now parentheses pop up, we have 1 plus 0.0625 divided by 2. Close the parenthesis for the natural log, and close the parenthesis for the denominator. So the answer is roughly 10.5 years. So t, approximately 10 years and a half. So if we want this principal, 11,000, to become 21,000 at this rate, we have to wait for 10 years to double, roughly. 10.5. Any questions on problem 14? Any questions on problem 14? Can you move on to problem 13? Yes? Okay, problem 13 then. We have log base 2 of x plus 6 plus log base 2 of x plus 5 equals 1. We should always ask ourselves what type of equation is this, and you will have to answer it's a log equation, very good. And then we have to remember that we either check the solution and the original problem if you don't like to state a domain, or you state domain. It's one or the other, but you have to use one or the other. So then, if I state domain, for the first one I will have to write that x plus 6 must be excellent, and then for the other one x plus 5 must be greater than 0. This is greater than -6, and this is greater than -5. I have to make a decision about the domain. It has to be the common domain. Both functions have to exist. Careful, careful. Here's -6 to infinity, and this is -5 to infinity. And I want the common area. Yes, so it must be -5 to infinity. Good. So only now I'm allowed to condense. You cannot condense before you state the domain on the original equation. Do not change anything before you state the domain. After you state the domain, you are allowed to condense. So let's condense. How do we condense the left-hand side? Yes? Log base 2, yes. Very good. If you want, if you don't want to, if there's any confusion, put brackets in there. And now we are ready to expand, not condense, not expand, but change it into an exponential equation, I meant to say. So let's do that. We always start with a base, and we go counterclockwise. Yes, equals this, but I will multiply it. So it's x squared plus 11x plus 30, or x squared plus 11x plus 28 equals 0. And I'm hoping for something easy to factor when you're ready.
X plus 4, x plus.
Very good. Indeed, I agree. So then you're going to come up with two options. Yes. So what we conclude?
Yes.
I will say yes, but I will say no. It can't work. It's not in the domain. Either one or the other of the logs will not be defined. Very good. Moving on. Unless you have questions, please. Any questions here? Any questions? Okay, then we have e to 11x minus 5 minus 3 equals 20,498. Again, we have to identify the type of equation. What type of equation is it? And then we have to identify whether it's completely cleaned up. If it's cleaned up, then we'll identify what we need to do next. Is it completely cleaned up?
Yes. No.
So what should I do then? Add 3, very good. E to the 11x minus 5 equals. So 1, 0, 5, I think. Is it 28,501?
Yep.
Good. So now it's completely cleaned up. And what will happen next then? Now we apply natural log indeed. Awesome. So natural log on both sides. So 11x minus 5, I should write times natural log e. But how much is natural log e? 1. That's why we don't write it. Very good. So that equals natural log 20,501. And then I have to add 5 and divide by 11. 5 plus natural log 20,501 divided by 11. Any questions? Any questions? Of course, if you'd like to evaluate, to approximate, I meant to say, to approximate this, then you can go back and check. Would you like to approximate, or you're comfortable with that? Or confident that this is the correct answer? Make up your mind. 1, 2, 3. Thank you. Yes?
I was going to say, let's
We want to check?
approximate. Sure.
Yes. So let's go into check. Excellent. So in parentheses for the top, careful. I see 5 plus natural log. Uh-oh, I didn't. In parentheses, 5 plus natural log 28501. And close the parenthesis and close the parenthesis for the numerator and divide by 11. So I got this approximation as 1.39 approximately. And then I go back to the original problem, which is e raised to, in parentheses please, 11 times the previous answer minus 3, no, minus 5, close the parenthesis, minus 3, and also minus 28498. You don't have to do that, but I'm showing you in other situations this is the best.
Oh, you mean
Yes, 28598. Sorry. Thank you. 28598. Is that correct now?
No, 4. It's a 4.
I'll eventually get it. 28498. Yes. When I press enter, if the answer is correct, what should I get?
0.
Exactly. Okay. So this is the way the calculator says 0, because this is what this means. 0.000000015. So this is correct. This is 0. Perfect. Next one. Number 11. So we have 9 raised to x plus 6 equals 81 raised to x minus 8. Now we normally, you know me, I always request not mandatory, but I request prime numbers. In this case, because it's 9 and 81, I'm going to let it slide. So I'm going to say this. Of course, you can apply natural log. You will get the same answer. But this is so much easier than applying natural log. So the left-hand side is 9 raised to x plus 6, and the right-hand side is 9 raised to 2x minus 16. And this is much more straightforward. I would recommend this. So what has to happen now? What is the final conclusion here? Two numbers are equal and they have the same base. Then their exponents must equal each other. X plus 6 equals 2x minus 16. So we have negative x equals negative 22, or x equals 22. Any questions? Moving on then. Okay, going backwards to number 10. Number 10 we're asked to condense. And we have 3 log 2x plus 1, common log, and minus 4, common log x. Ready? What do we have to do first before we try to condense, before we try to do anything? We must get rid of a portion. Which portion of what I see here? Which pieces? Exactly this number and this number. Otherwise we can condense, right? Where do these numbers come from? Yes. So log 2x plus 1 to the third and log x to the fourth. Do we agree with this step? Yes? Final step now. Remember what we said a long time ago? If a log has a minus in front, must come from or must go to, it doesn't matter where. Excellent. So this is only one log. So please do not write log of over log of. I know it's very tempting, but this is log applied to a ratio, and the top is 2x plus 1 to the third, and the denominator is x to the fourth. Questions, please. Number 9. We have log base 4 of the square root. No, I'm sorry. It's the 7th root of a to the 6th, b minus 1 to the 3rd over 16. Okay, so first we have to start with the 7th root. The 7th root goes in front as 1 over 7, log base 4 of a ratio. Now we keep 1 over 7, and in one step we expand this because we can. You don't have to apply the power rule just yet, but just give me the final simplified form. Yes, log base 4 of a to the 6th. Excellent. Excellent. Yes? b minus 1 to the 3rd? Minus, indeed, log base 4 of 16. See, if you understand this sequence, then you'll not have to think too much. Now, of course, the powers will come in front, and I will have to distribute 1 over 7. Before we do that, I have to concentrate here for a second, because this is a number. 4 raised to which number is 16? 4 raised to which number is 16? Counterclockwise. So this whole thing will be replaced by 2. Excellent. So this is 2. And now we will distribute 1 over 7 and put 6 in front and 3 in front respectively. And we're done. 6 over 7 log base 4 of a plus 3 over 7 log base 4 of b minus 1 minus 2 over 7. Each and every term gets multiplied by 1 over 7. Please, any question? I'll say it again. Bring the power and multiply by 1 over 7. Bring the power down, multiply by 1 over 7, and 2 times 1 over 7. Everything gets 1 over 7. Better? My pleasure. Good. Moving on. Other questions here, please? Other questions here? Okay. Where are we? Right here. Number 8. The percentage, we are given a function f of x, 62 plus 35 log x minus 4. Before we even look, can anyone give us the domain of this function? What will you normally write? And then we continue reading. Yes, you will write x minus 4 equals 0, greater than 0. So then you will write, however, they're giving us something else, where x represents the girl's age from 5 to 15. Okay, so it's okay, it's fine. So x, they say it's between 5 and 15, because the domain is greater or equal to 4, which is fine. 5 to 15 is good. F of x represents the percentage of her adult height. Percent of adult height. Okay, use this function to determine approximately what percent of her adult height girls are, of their adult height girls are at age 14. So it was determined experimentally that at every age, we get to a certain height that represents a percentage of the maximum height that we will attain through our life. And this is the model. They are giving us 62 plus 35 log, common log of x minus 4. So when we plug in x anywhere between 5 and 15, the answer that we get will be a percentage at that particular age of the maximum height that we will attain. we're asked to determine the percentage of adult height for girls that are 14 years old. Of course, the model is not perfect for everyone, but approximately. So, any suggestions? Anything?
Do you just replace X with 14?
Absolutely, there is nothing else. And we cannot perform the operations. I mean, actually we can. I just realized. How much is 14 minus 4? How much is common log of 10? 1. How much is 1 times 35? 35. How much is 35 plus 62? 97%. So what does that mean? That after the age of 14, girls appear not to be increasing in height that much. At the age of 14, they got to 97% of their total height, maximum height that they will attain. Any questions? Okay, next question. We are asked to graph log x plus 3 minus 1. Ready? Okay, so we're asked to use transformations and graph this graph. First, we have to determine its domain. What do I have to write to find the domain of such a function? No, I have to write the inequality first. I cannot solve before I write the inequality. What is the inequality? Yes? Greater than? Not equal to? I didn't say you said that, but I just make a point. I have to write that x plus 3 is greater than 0 and x greater than negative 3, which makes the domain this. Because the domain is this, negative 3 to infinity, I know the vertical asymptote without even graphing. What is the vertical asymptote? Of course. Of course. Vertical asymptote. Great job. Okay, so what is the base function? And we see two transformations. One, this is log of x plus 3, and the other one, which is log of x plus 3 minus 1. Okay, so what is the base function? Can anyone give us the base function? Log of x, of course. Common log x. What transformation is this? Remember, first we have to identify whether it's a transformation on x or on y. If it's a transformation of x, something will happen horizontally. If it's a transformation of y, something will happen vertically. So compare these two and say, left 3. Perfect. And then number 2 is not a transformation on the base function. Number 2 is a transformation on this. Down 1. Excellent. I am going to add here, find x and y intercepts algebraically. After we graph it, we haven't finished. So, or maybe it's wise to determine them first. So, since the domain is negative 3 to infinity, I will be able to find f of 0. How much is f of 0? F of 0 is log 0 plus 3 minus 1, which is log 3 minus 1, which I have no idea what it is. So I will put in the calculator. Log 3 minus 1. And I get negative 0.52, approximately negative 0.52. So 0, comma, negative 0.52. And that is the y-intercept. How do I determine the x-intercept? Yes, y equals 0, which means log x plus 3 minus 1 equals 0. How do I solve this? Add 1 to both sides. Awesome. I have to clean it up. Max possibilities, everything. So I have log x plus 3 equals 1. And I know that this can easily be changed into an exponential equation. Yes. 10 to the first power equals x plus 3. Therefore, x must be 7. So 7, comma 0 is the x-intercept. So I know what to expect. Now you told me to first graph log common log x. So is it an increasing function on all its domain? Is it a decreasing function on all its domain? What is it? It's increasing, it's log, and it has to cross at 1, 0. Base function, common log, has to cross at 1, comma 0. Good. The first transformation, you told me to shift this left 3. We already identified that this is a vertical asymptote, and when we shift a graph with a vertical asymptote left and right, and it has a vertical asymptote, what do I have to shift first? Exactly, the vertical asymptote. 1, 2, 3. So first I have x equals negative 3. Perfect. So now please tell me, where does this point move? If you tell me where it moves, then I will be able to graph the function. Say it again. Very good. 3 to the left at negative 2, 0. Very good. So this is log of x plus 3. Excellent. Now what? Down 1. Remember, we already determined the x and y intercepts. 1, 2, 3, 4, 5, 6, 7. And negative 0.52. And this point moves here. Ready? This is the final graph. F of x equals log x plus 3 minus 1. Questions? Moving on. Questions, please? Okay, problem 6. So we have a bar graph here, and we have two functions. The bar graph shows the percentage of people 25 years of age and older who were college grads in a certain state for 7 selected years. So 1950, 60, 70, 80, 90, 2000, and 2006. Fine. The functions below model the percentage of college graduates among people ages 25 and older, F and G, X years since 1950. So I will immediately write f of x and copy it. I will copy g of x, and I will say x equals 0 for 1950. So we're asked to talk about what happens in 1980. So in 1980, I see that this is, the answer is 17.0. So this should be f of x should be 17%. What is x for 1980? If x equals 0, represents 1950. What does 1980 represent if 19 50 is x equals 0. 30, very good. So with the graphing calculator, let's do that. So let's plug in two functions in y equals. Clear if you have anything in there. The first function should be entered at 6.19 multiplied by 1.029 to the power x. The second function is entered as 37.3 without parentheses because it's only one number. And also in the numerator. But the denominator needs parentheses. 1 plus 6.1 times e2 raised to 2 in parentheses negative 0.052 x, close the parenthesis for the power and close the parenthesis for the denominator. And now I go to second and table, and I plug in 30. The first function, which is the exponential function, gives us 14.6%, and the second one gives us 16.3%. And what is the actual number? The correct answer? 17. The correct answer is 17. So f of 30 was, I'm going to copy them. F of 30 was 14.6%. G of 30 is 16.35%. And which one of these two models will you choose for 1980? Remember, we haven't checked for the other models. But specifically for 1980, which one of these two will you choose? And you will say it's not perfect, but it's the closest. G, indeed. So I will say yes to G. For 1980, use G of x. I don't know if for the other ones I'll have to use the same thing, or maybe the first one is better. I don't know. But the question was only asking us to look at 1980. Any questions? Any questions? The exponential function, problem 5, f of x, 542 times 1.026 to the x power. X millions, so this is in millions. X equals 0 for 1970. Complete parts A through E. The country's population in 1970 was, in 1997, in 2024, in 2051. So 1970, 1997, 2024, and 2051. So what is x for 1970 again? What is x for 1997? What is x for 2024? And what is x for 2051? So 24 minus 70, it's 54. And 51, 2051 minus 70, it's 51 plus 30, which is, right? Yes, 1, 81. Perfect. So that's what we have to put in the graphing calculator. So in y equals, clear whatever you have, and we punch in 542 times 1.026 to power x. Okay? And now we go to second and table. Second and table. Okay, I guess he has to do its thing. He didn't take the second. So in y equals, we had, one more time, I had 542 multiplied by 1.026 to power x, second and table. And I want I went 0, 27, 27, 54, 81. So it happens that f of 0 is 542, of course. We didn't need to calculate that. Of 27, 1084. F of 54, 2168. And f of 81, 4335. Okay, what do we conclude? So this is in millions. There is a question here. What appears to be happening to the country's population every 27 years?
Yeah.
Doubling, very good. Doubling every 27 years. Very good. Well done. Thank you. Number 4. Suppose you have 11,000 to invest. This problem does not give us the model, but the model is up here. So it may be given in a different problem. It will be given to you. You do not have to memorize it. So we have two possibilities. P times 1 plus R over N raised to NT, or A equals P E to RT. And we're told we are investing, so the principal is 11,000. Which of the two rates would yield a larger amount in 5 years? So T equals 5 years. So one interest rate, R1, is 0.12, compounded monthly, so N equals 12. And the other one is R2 equals 0.1191, and and this is continuous. So they're asking us to compare. Which of these two will yield a better, will give us a better option, will yield a better amount for us? Is it with a interest compounded 12 times a year with an interest rate of 0.12, or with the interest compounded continuously and the interest rate 0.1191? So we have to put all the information in the model with 0.12 and n equals 12. And in the second model, we would put the interest rate of 0.1191. So let's do that. Oops, 7, 8, 9. Sorry about that. So A equals 11,000 in parentheses 1 plus 0.12 divided by 12 raised to 12 multiplied by 5 years. And that will be our first amount. And the other one will be 11,000 e to 0.1191 multiplied still by the same amount of years, number of years. So it's 5. So with a calculator, please. So 11,000 parentheses 1 plus 0.12 divided by 12. Close the parenthesis, power in parentheses, unless you multiply and you put 60. But if you put a product, please put parentheses. And then the other one is 11,000 times E. And in parentheses, we have 0.1191 multiply by 5 and close the parenthesis. So the first one gives us 19983. 0.66, and the second one gives us 19953.31. So which of these two would you prefer? Although the difference is not huge, but which one is best? The first one, 12% per year, compounded twice, 12 times per year, or the second one, continuously compound interest at 0.1191. And this is a very good comparison, right? So what is best? A lower rate, although it's by a little bit lower, tiny bit lower. And it gives us a little bit less. So we will choose number 1. Better. Any questions? Any questions?